Hey everyone, welcome to SingularityComputers Client Build 4, Part 5. Now there's still a lot for me to cover in this part of the build log. It's going to be focusing mainly on the test results. The client has asked me to do a factory overclock. So nothing too extreme, I'm just going to be taking the system to 4.4 gigahertz. This requires another 24 hours of validation. So I'm going to be showing the test results for stock clocks and also the overclock. So this includes temperature results and performance results. So there's a lot of test results to cover. Also in this video I'm going to be giving you a detailed look around the system and covering some of the things that I haven't already talked about, such as the cable management and the lighting and a few other little details. This is actually the final part of the build log, so I'm going to move on and get started on giving you a detailed look around the system. So the lighting that I've used in the build. In the EK Supreme HF I have two Phobia red 3mm LEDs, and you can see the cables are high quality sleeved black. The other lighting that I've put in the build is a Bitfinex Alchemy red 30cm LED strip that goes all the way up the inside of the 5.25 inch bays just here, and you can see I've cable tied it on, and this is so that it doesn't fall off. I've seen these things peel off, you know, after a short time. Now the front panel cables, that is the only place that you can put them. You can't go down to the bottom with them because there's actually no room to get it around this bar here. So I'm really glad that I put the res and the pump where it is, because it hides those cables a lot. Being really picky, and if I was going to go absolutely all out with this, I would have put Bitfinex Alchemy extension cables on all of those just to, you know, make it look even better. But those cables are not too bad. So okay, over here, the 8-pin EPS CPU power cable, I had to put a Bitfinex Alchemy 45cm black extension cable on that, and I absolutely love these Bitfinex Alchemy extension cables. The sleeving is soft, it's not shiny like a lot of the other sleeving. You can see that the Phobia LED cables there, the sleeving is shiny. Also, they don't use heat shrink, they run the sleeving straight into the connectors, which just looks great. So I used Bitfinex Alchemy extension cable there. Also one for the 24-pin motherboard power, which is another 45cm extension cable. I had to use two 45cm Molex Bitfinex Alchemy extension cables to get up to the easy plug there, which supplies extra power to the graphics cards. I really did want to connect that up, you know, because I am using multiple graphics cards, so I thought it was important. And there is actually another extension cable, another Bitfinex Alchemy extension cable powering the LEDs, which I'll show you all that once I get around the back of the build. The 24-pin motherboard power is all uncovered for the last like 2 inches. So that was showing up just here, and it looked absolutely terrible. You know, it was just taking from the build like nothing else. Same with the 8-pin EPS, plus the 8-pin EPS wasn't actually flexible enough to get around the corner there and go out the back. I didn't add them to the PCIe power cables because I think that the stock ones really don't look so bad. Mainly once the side panel is on, you know, the side panel window hides a bit of it, and they're kind of mostly out of sight. The other reason that I didn't use the Bitfinex Alchemy extension cables here was because there's already enough cable length in the bottom compartment. I didn't want to add any more. You can imagine all those 4 cables with single sleeved extension cables on them would have just added so much more cable mess down here to deal with. Okay, so the next thing is the optical drive. Now, I don't like putting optical drives in builds because they ruin the aesthetics. You know, it's taken away from the front of the build, and also the inside as well, and you know, you've got to run extra cables up there. But seriously, if it's requested, if it's needed, then obviously I'm going to add it. But I used here an NZXT 300mm extension cable. and I've used Phobia SATA 3 SATA data cables. They're actually sleeved, you can see the heat shrink just there. I used another one on the storage drive. I couldn't use one on the SSD, I'll show you why when I get around the back. I've already taken you around the loop. I showed you the configuration of the loop in part 3, as well as all of the fittings and everything, so yeah, talked about all of that. Now moving on to the bottom compartment. Now the way I've done this, if I had have put all the cables onto the bottom, then they would have come up to about here. If I'd have put them on the top, they would have come down, you know, to about the same, taken up the same amount of room. It doesn't matter where I put them, they're still going to take up the same amount of space, because I've tied them as tightly together as I can. And yeah, I thought that this was the best way of doing it, because they're in a position that they're going to stay in. They're all tied tightly. I've used a combination of these Nexus Velcro ties and also cable ties. They're certainly not going to go anywhere. They're holding the tubing down. I explained why I added this extra tubing length already, and also this extra tubing length up here. It's for draining. So obviously you could call it a little design flaw that the cables have to end up, you know, blocking the airflow here. But seriously, the difference that it makes would be less than 1 degree. I'd say not even 0.5 of a degree having these cables here. Because the power supply is sucking, you know, the power supply fan is sucking air out the back. And the air is not just hitting a wall here and stopping and going nowhere. It can easily go through the cables, it can go around the cables. You know, it's going to create a little bit of turbulence, but it's not going to stop the air. And when I chose the fans, I knew that I was going to use this radiator, and obviously I knew the radiator's specs, that it has a 20 FPI, a dense fin array. I knew that I was going to use the filters, okay, because 20 FPI means a fair bit of flow restriction. Filters mean a little bit of flow restriction, and having the cables here means just that touch more flow restriction. So taking all of that into consideration, I used a more high performance fan than I normally would. Normally every build I go for complete stealth, complete silence, so that you can't even hear the water cooling system whatsoever. I don't like being able to hear any fan noise at all. But with this build, because I knew that I was going to have the flow restriction from the radiator, the cable management and the dust filters, I sacrificed some of that silence for a more high performance configuration. So now I'm going to go around the back of the build. I'm just going to take a quick look at the top before I do that. So just to look down through the top, I love the look of the red light shining out through the ventilation. Now, I don't like pass-throughs. I actually absolutely hate them normally on normal cases. But I was going to use a converter, because you don't get a converter with this case, you just get the USB 3 pass-through. But anyway, what I started off by doing was passing that back through here and using a converter from USB 3 to USB 3 motherboard header, and I plugged it in, but it looked terrible because the converter has these huge big plugs on it. It's not sleeved. It was in the way, and it just really took from the aesthetics of the build. So I thought, because of the configuration of this case, it's out of sight, because, you know, once the top panel cover is on, you can't see it. I tucked it back down there nicely. It's only taking up an extra 2 USB 3 ports on the back, and moving those USB 3 ports to here. So, you know, instead of having 6 USB 3 ports, it's got 4 USB 3 ports, because I did it this way. But it looks a whole lot better. Anyway, now let's take a look at the back. Yes, I stuck the Republic of Gamers case badge just there. I think it looks great. So I've already talked about these front panel cables, so I ran them around the back instead of inside the drive bays, because this is the only place to get them properly out of sight, and they're not in the way here anyway. Now, yeah, so that's all the front panel cables there going to the motherboard. Down here I've got 2 SATA data and the pump power. Now, I had to use a different SATA cable on the SSD because I need it to be straight on both ends. You can see a 90 degree wouldn't have worked here, there's not enough room. And on the other end it was the same thing up against the motherboard tray, so I couldn't use the nice phobia sleeve cable. I just had to use one of the ones that came with the motherboard because it was the only one that I had with straights on both ends. But it's completely out of sight from the front anyway because of the way I configured the cables. So you can see all the SATA data cables are tucked down the back of the fan there. They go through there. So moving on to the rest of the cable management at the back here, you can see there the 8-pin EPS. So that's actually where the first Molex extension plugs into the second one for the easy plug on the motherboard. That's where the Molex extension plugs into the LEDs. And the 8-pin EPS extension actually goes right down and into the bottom compartment and then plugs into the power supply cable. So anyway, that's all tied back there nicely. Okay, the dust filters. Now, every client build that I build, I need to build it for longevity. It needs to last as long as possible with minimal servicing and maintenance, and any servicing and maintenance needs to be as simple as possible. So that's why I always use dust filters. They're very important to make maintenance easy. Because without these dust filters, when you dust clean the radiator, which would be after, between 3 and 6 months depending, you'd need to pull the radiator out, take the fans off it, clean all the fans, possibly even wash the radiator with water, because sometimes that is the only way to get the dust out of between the fins. This radiator in particular does have intralouver dust protection. It's like designed so that dust doesn't go in, but I tell you, dust still does get in between those fins, and when it does, you have to wash it. Now the dust actually looks a lot worse through the camera for some reason, but it's really not that bad. It's actually barely visible from back where I am. This is after 3 to 4 days actually it's been now. This dust is here because, for one, these dust filters are doing an excellent job, and secondly, those fans are sucking an incredible amount of air through that radiator. Okay, they are cycling so much air through that radiator that, that means you get an extra dust buildup. Anyway, I think I've talked enough. So this is the final shot of the inside of the build. I'm now going to put the side panels on and then give you a look around the outside of the build. Okay, here it is, the finished product with the side panels and top panel on. Now remember, I did a detailed review on this case. It was actually a 45-minute review. So if you want every little detail on this case, then make sure you check out that review. Just to look over the top, I absolutely love this top panel cover. Just looks great. There's so much ventilation in it, and also down the side, or both sides, to allow for all the air that the 180mm fans push up towards the top, as well as the 120mm exhaust. I'll just show you you can see the quick disconnects through the bottom there. To know that there's water cooling components tucked down there as well when you look at the build is great to see. Anyway, I'll go around the back now. The other side panel is identical except minus the side windows, so there's not much to see back here. And you can't really see, you can just see the filters through that ventilation. Anyway, there we go. I just thought I'd give you a quick listen to the system, to all of the fans and also the pump. Now from back here I can just hear the system. It's actually being drowned out by my air conditioner in the background, so it is pretty silent. But as I've said, I have sacrificed some silence for performance with this build. I'll just give you a listen to the pump. Remember, close up you're going to hear a lot more noise. Okay, I can't hear the pump at all. You know, I can never hear the MCP 35X or the MCP 655. Those are the two pumps that I always use. I've never been able to hear either of those except when there's air in the loop. So the 180mm fans, now this is on low. Now the 180mm fans have high-low switches up here on the top panel at the back of the build, and I've just switched both of them from low to high. Now I certainly don't recommend using these on high because they are pretty loud. This 120mm fan is very silent, by the way, but yeah, I would just leave these fans on low. So you can hear they do have a fairly decent whine to them. It doesn't sound good. I wouldn't be turning them up unless you're doing some serious overclocking and benching. Now for a listen to the noise blocker PK3s. So I'll just put the camera right up against the filter. So you can see that they're still very silent, but I would say a little bit on the high side of what I would call silent. So normally I'd go for less than 20 decibels, like 15 to 20 decibels. But I'd say, yeah, I think the PK3s are 27 decibels when maxed out. So there we go. Okay, now for the test results. So first up I have all of the temperature results. So this is just showing you the effectiveness of the water cooling loop. And the only real way to show you how effective it actually is would be to first show you the air-cooled results, then the water-cooled results, so you can compare the two. Unfortunately, I can't do this with this system, but those of you who understand water cooling will understand how good these results actually are. Because, you know, obviously you need to take into consideration the ambient temperature, which is something that so many people don't do. Because I have such a high ambient temperature, I get so many people coming along and saying your temperatures are so high, because they just have no clue that the ambient temperature, the temperature of your room, directly affects the temperatures of the hardware. Obviously, the temperatures across the face of the earth are very, very different. So for example, where I live, it's almost all the time in my office 33 degrees Celsius, but then in Europe it might be 20 or even 15 degrees Celsius in somebody's office, and it might be the same in America. And that massive difference in temperature, you know, that's up to like a 15-degree difference, has a direct effect on the hardware. So for example, if my CPU, well, actually in the 24-hour Prime 95 testing, the CPU got up to, I think it was 54 degrees on the hottest core, and minus 15 degrees from that, you know, for a colder climate, and that's a lot cooler, you know. So it makes a huge difference, and you remember, it has a direct effect. If you want a comparable temperature, you can't just go comparing my temperatures to somebody else's temperatures, or, you know, you can't go comparing direct temperatures. What you need to do is get the delta. Okay, to get a delta temperature, you need to minus the ambient temperature from the component temperature. Then you have a comparable temperature. So now I'm going to move on to the temperature testing and then all of the performance results. So I just need to say that the temperature results were very similar, you know, in my temperature testing to what they were during the 24-hour Prime 95 test, which for that I used large FFTs, and also for the 12-hour Unison Heaven benchmark test. Okay, the differences were 2 to 3 degrees. Okay, first up in the temperature testing, the system idle test. So I cold booted the system and it's been idling for 1 hour. The ambient temperature is a little bit cooler today than it normally is when I do my testing. It's currently 28 degrees Celsius. This is the temperatures of the CPU cores. So 6 temperatures for the 6 CPU cores. maximum temperatures that the cores have spiked up to down there. Okay, this is the temperatures of one of the graphics cards. So 32 is the max that it's reached in the 1 hour, and keeping in mind that of course the graphics cards and CPU is water cooled, whereas the motherboard is not. And now for the temperatures of the motherboard. So 29 degrees currently on the motherboard and 38 degrees currently on the PC8. Okay, now for the CPU load test. So Prime 95 has been running for a bit over an hour. The ambient temperature is now 30 degrees Celsius. There's the temperatures of all of the cores, and you can see there the maximum temperatures as well. You can see the CPU is still under 100% load. Prime 95 is still running. And just a quick look at the PCH and motherboard temperatures. So you can see that they're not much different compared to when the system was idling. Okay, now moving on to the overclocked CPU load test. So I've overclocked the CPU to 4.4 GHz, 1.35 volts. And Prime 95 has again been running for 1 hour, large FFTs, it's still running. Those are the current core temperatures and the maximum temperatures that the cores reached. The ambient temperature is currently 31 degrees Celsius. Okay, Prime 95 has now been up and running for about 2 hours, and I just wanted to show you the temperatures of the motherboard, just to show you that the motherboard really doesn't get that hot. So it's still 31 degrees Celsius, and I thought I'd just show you what the system looks like in the dark as well. But yeah, this is what I wanted to show you. Look at that. The motherboard is 35, and the PCH, which is the X79 chipset, is 45 degrees. So yeah, the stock motherboard cooling is certainly adequate. Okay, now moving on to the graphics card's load test. So I've had the Unigine Heaven benchmark running for 1 hour, and the maximum temperature that one of the graphics cards reached is 46 degrees Celsius. Now this is an incredible result because this is a delta temperature of 13 degrees Celsius. So that's 13 degrees above ambient. Now I'll just show you the temperatures of the motherboard and the PCH. When I first exited the Unigine Heaven benchmark, the motherboard was 32 degrees and the PCH was actually 42 degrees. Okay, now moving on to the performance results. So I have a whole bunch of benchmark results in there, including benchmark results for the SSD. I'm going to show you all of the results in screenshots, and I have the stock clock results and also the overclocked results side by side so that you can compare the two. So first I'll show the stock clock result and then the overclocked result. Keep in mind that for the overclocked result I have the CPU running at 4.4 GHz, 1.35 volts, and I also have the memory running at its XMP profile, which is 1600 MHz, 99924 CR2, 1.5 volts. So certainly some impressive results there. You can see how much even that small overclock affected the performance. I mean, just imagine if I were to overclock the CPU to say 4.8 gigahertz, which really is not difficult with this hardware, and then I could have overclocked both the graphics cards as well, and that is one of the really awesome things about the 7970. It overclocks like all hell, and the performance gain from overclocking these graphics cards is huge. So if I were to overclock the graphics cards and the CPU as far as they could possibly go, the performance gain out of doing that would just be absolutely massive. I was really impressed and actually surprised to see how big the performance gain was just from 4.4 gigahertz. So some incredible results from an incredible system. Okay, now for a look at how I pack my systems up for shipping. So the first thing that I do is reinforce the insides of the system, and for this I normally use cable ties, you know, depending on the system. Well, every system so far I've used at least some cable ties. Now the bottom compartment, nothing in there is going anywhere. That's all tied into position, so I don't need to worry about that. But I need to take into consideration if the system is dropped during shipping. It only really needs to be dropped from an inch off the ground, and it's going to put a massive shock, you know, into the system itself. Even though I'm wrapping it up in bubble wrap over and over again, you know, maybe if it's even dropped from 6 inches, you know, if it's being carried by a couple of men, that is a possibility. So I have to consider all of the potential scenarios. You know, I do use fragile freight and all of that, but I'm fussy. I prepare for the worst. So what I've done, I need to consider, you know, if it's dropped on this side, on the top, on the front, or on the bottom. Okay, so if it's dropped on the bottom, the graphics cards are pretty safe, because then it's going to be pulling down, you know, here. So there's no reinforcement needed there, but there is for the res and the pump. So what I've done with the res and the pump, I've tied them up to here, and what I've done is I've pulled all these cable ties really tight, but they're pulling not on the components, but they're pulling against each other. So the component is being held in, you know, in its exact position, but there's heaps of pressure, you know, in opposite directions on the cable ties. So I've pulled it up to there, and I've pulled it down to there in the opposite direction. I've pulled the res and the pump together with this cable tie here. I just have to put that piece of foam there so that the cable tie doesn't touch and rattle against the res and scratch it. I've also pulled the res up to the top. Now the cable ties are certainly not tight enough to rip fittings out of components and things like that. They're just tight enough to hold the components into position. Now, dropping it on this panel and this panel, I've reinforced it both ways, here and here. And I've also pulled the graphics cards together to stop these two from pulling the graphics cards apart. So anyway, that is all the reinforcement that's necessary. The memory will stay in its slots. I don't think that'll be a problem at all, because it doesn't come off the motherboard far enough. It's not heavy enough to, you know, to be a problem. I'll be putting, the other thing is, you know, it could be dropped on this side, like that way, and also on the other side. If it's dropped on the other side, that's okay, because that's just going to push everything into the slots. The res, the radiator, everything will be okay because of the way I've mounted it all. It doesn't need any more reinforcement. But if it's dropped that way, on that side, then the graphics cards could potentially be ripped out of their slots. So to stop that, I'm packing 2 pieces of foam very tightly. I'm going to be putting them here, and then I'm going to be pushing the side panel onto them, and that will hold the graphics cards into position. So the foam will be sitting up against the window of the side panel, and yeah, that'll be on there very, very tightly. But the side panel will be reinforced when I put it into the box. The box will hold the side panel on, so you know it won't like bulge the side panel out. So this is how I pack things. It's covered in a whole lot of rubbish bags, so it could basically float down a river and still not get any water inside of it. So it's also completely wrapped around and around and around in bubble wrap, so certainly no damage is going to happen there. Alright, it's now time for me to bring this build log to a close. So I've really enjoyed building this system and working with such amazing components. There's going to be a lot more of these in the future. I've actually got a few more lined up right at this point in time. This is an incredible build. I'm proud of this system. I've worked extremely hard on it. You know, I always make sure that everything is as perfect as possible. I try my best to tend to every little detail. I hope you guys enjoyed this build log. I certainly did. Thanks for watching. Please subscribe, like and favorite if you want to see more.